حضرتك عارف السؤال اللي هو بيبقى 4 by 4 مثلا matrix بعدين بيبقى فيها K أو H أو يعني variable.
نحل مسألة زي دلوقتي. Either for the rank, okay, but you will have to go through the solution of the midterms that we already did in week number 6. Okay, if you remember, we did a huge revision before we go to vector spaces, and we already solved the previous midterms. You will have to go through. So now I will give you a problem which is really very nice about this part. It's about the classification of a system of equations, and this is really very important. It's a classical question that usually will come with any in most of the exams, by any means, by anyhow. Either if it was a direct question, or if it is a multiple choice, or by anyhow, as I told you. All of this, or this question key, is to know exactly how to classify a solution of a system of equation. If I have a system of equation, the solution set for a system of equations, you are in between two general cases. You have two general cases. First, in consistent system of equations and consistent system of equations. Of course, any system of equations, it will be A dot X equal to B at the system we already saw. The first step is to put the augmented matrix. The augmented matrix, it is actually two matrices put together. So it's a coefficient matrix, this guy, and with the B matrix, the result matrix. So I would have the augmented matrix equal to the coefficient plus the B matrix, as you can see. Okay? So mainly, that's the solution set of a system of equation. I have two matrices, A and B. The classification, if I have inconsistent system of equation, the result, or a consistent system of equation. When I should have inconsistent system, if the rank of the coefficient matrix is not equal to the rank of the augmented matrix, which is A and B. They are not equal to each other. Mainly, the rank of the smaller matrix in general will be less than the rank of the general matrix or the overall matrix. So this is really very important, okay? That's the coefficient matrix, and that's the augmented matrix. So you will have the rank of A is less than the rank of A and B. This is major. This is rank of A doesn't equal to the rank of the augmented matrix. You will have inconsistent system. Do you remember what the rank? What's the rank?
Non-zero.
It is the number of non-zeros in the reduced echelon form. What's the reduced echelon form? Once you try to solve your problem and reach as near as possible to a unit matrix. This is after you do your row operation. يعني لما احنا كنا بنحل سوا دلوقتي وصلت للشكل النهائي ده كان يونت ماتريكس صح؟ اليونت ماتريكس دي اسمها ريديوسد ايشن فورم. والرانك هنا كانوا كام؟ 3. ليه 3؟ لأن الفيرست رو كان 1 دبل 0، السكند رو 0 1 0، the last row 0 0 1. يبقى how many non-zero rows؟ 3. Okay, يبقى إذا to have inconsistent system, the rank of A shouldn't equal to the rank of A plus B. I can write also rank of A, okay? The rank of A is less than the rank of A and B, which is the augmented matrix. To have a consistent system of equations, if it's gonna be a consistent system of equations, the ranks should equal to each other. So rank of A should equal to the rank of A given B, or A and B, or the augmented matrix. So the smaller and the longer matrix, both of them have the same rank. They are equal to each other. This is gonna give you a consistent system. Then it will lead you to another classification with consistent system. Either consistent in dependent solution and dependent solution. What's the independent solution? The unique solution. This is called a unique solution. Will happen when the rank of A is equal to the rank of the augmented matrix is equal to the number of variables.
No, we have to leave because we have to.
Don't worry, I will continue. I will continue, okay? And it's recorded, okay? Okay, for the dependent solution, you will have the rank of the A matrix is equal to the rank of the A given B matrix, and it is less than the number of variables. In this case, you will have a dependent solution. Remark, the dependent solution, in the case of dependent solution, it's the infinite number of solutions. You can have here what's called a degree of freedom or a degrees of freedom or a number of variables. It's very, very simple. All you have to do is to get the difference between n minus r. So you know the rank, you know the number of variables, get the difference between them. This is what's called the degrees of freedom or the number of free variables. This is mainly the map for how to classify a system of equations. So the main issue is trying to solve, to reach a reduced echelon form. Once you have a reduced echelon form, you will be able to charge. This is one of the classical problems. I would like to solve it with you, okay? And it's also about this part. This is really a very important problem. Your exam, inshallah, will be, I believe it will be accessible. It will be easier than the previous years. It's not simple, but it will cover everything that you had taken. You should, as I told you many times, go through, number one, the previous exams, because it's gonna be similar to them. And they are solved in the 6th week for this year. You can find them on the YouTube, solve it with you. It's very, very simple. Also, you will have to review the propositions, which is really very important. The inversion propositions and the transposition propositions are really important part of our course. It has plenty of ideas, okay? Let's see this problem. He wants you to solve and explain your solution for the following.
I will answer it inshallah.
Okay? And he will ask you to find the values of alpha and beta. Okay, based on them, just a second please. Okay, I need you to identify the values of alpha and beta. For them, you will have a unique solution, no solution, infinite number of solutions. That's a classical question in linear algebra. And it tests your knowledge in depth about knowing the previous classification. It's very, very simple. All I have to do is to use this system of equations and to put it in an augmented matrix form and start trying to identify the key of judgment or outranking, which will be a function in alpha and beta in these constants. This is really very simple. So it's going to be 1, 1, 1,
3.
then you will have 3. For the second row, you will have 2,
3.
then you will have 3 and alpha, and it's equal to beta. The last row will be 1,
2,
and then you will have 2, 2,
6.
and 6. In such a case, that's an abstract lock for the augmented matrix. I will try as much as possible to move the alpha and beta, or the judgment elements, to be in the last row, if it is accessible for me. So I would start also trying to reach the echelon form or the reduced echelon form. The easier for me, I will do it. So I would start with trying to force the elements beneath the pivot of the first row to be zeros. So this is going to be 1, 1, 1, and 3. Then I will need this guy to be 0. And I will replace these two rows also. So I will move the third row to be in the second row. And also will multiply by 0 and then it will write. And so I will do more than one step at the same time. So multiplying by -1 plus 1, the result will be 0. -1 plus 2, the result will be 1. -1 plus 2, the result will be 1. -3 plus 6, the result will be 3. So I've replaced and multiplied the first by a negative and the other. Now, this guy is in the third position. I need 2 to be 0. So I will have to multiply the first row in -2 and add the result on this guy and write it in its position. Okay, I will start. -2 plus 2, the result will be 0. -2 plus 3, the result will be 1. -2, okay, it's gonna be -2 plus alpha, so it's gonna come up to alpha minus 2. -2 times 3 is gonna be -6 plus beta, so I will have beta minus 6. This is why I've preferred to move the row with the constants to be the last row, if possible or accessible for me. The second step. The first column is already adjusted. I will go hunting the second column. So I will start with the pivot. I'm lucky. The pivot is +1. I will keep it this way. So starting the next step, I will write it here. Okay, the second row will stay the same, which is simply 0, 1, 1, and 3. I need to use this pivot to force this number to be 0. So I will multiply this row by -1 and add it on the last row. Start. -1 times 0 plus 0. -1 plus 1, the result will be -1 plus alpha minus 2, the result will be alpha minus 3. Same. -3 plus beta minus 6, you will have beta minus 9. I can stop or I can continue, it's really up to you. Okay, I need this element also is equal to 0. I will continue this step, multiplying by -1 and adding on the first term. -1 plus 1, the result will be 1 plus 1, the result will be 3 plus 0, so the result will be, okay, stop. Now I've came to take a decisions. First of all, look to this guy. If alpha minus 3 is equal to 0, the rank of the smaller matrix will be, how many rows not equal to 0? Will be 2. So I will start to take the judgment. So I will do like this. Number 1, if this element is not equal to 0, which means alpha minus 3 doesn't equal to 0, what's gonna happen? يبقى rank 3, which is gonna develop a unique solution. Because this matrix will be rank 3 if alpha doesn't equal to 3. لو أي رقم تاني غير 3. يبقى this value is not gonna be 0. So how many non-zero rows? I'm talking about the smaller matrix.
3.
Remark that the smaller matrix is apart from the bigger matrix. So once the smaller matrix, the rank is 3, the bigger matrix will be 3 also. So it's going to develop a unique solution. This means alpha doesn't equal to 3. And the result, I will have a consistent and unique solution for any value of beta. I didn't mention beta. Whatever you put beta. So whatever this guy is gonna be, this value, it's not gonna be 0. So you will have a rank of 3. So you will have a unique solution. طيب, what happened? Second case. If alpha is equal to 3, what's gonna happen? If alpha is equal to 3, then this row will exist. That row will exist. 2 rows. This guy is gonna be 0. So the rank will be 2. But the rank of the bigger matrix depend on beta minus 9. هنا هيبدأ يظهر ال values of beta. So if alpha is equal to 3 and beta is equal to 9 in specific, هيبقى ده بيساوي 0 وده بيساوي 0. يبقى كده أصبح the rank of the smaller matrix is 2 and it's still equal to the rank of the augmented matrix. In this case, the rank overall is equal. يبقى in this case, rank of A equal to the rank of the augmented matrix, which is A and B. And in this case, I will look to the number of variables. The number of variables is 3, while the rank is 2, which means those guys are less than 3. In this case, you will have a consistent infinite number of solutions. The last step. يبقى third option, you will have L alpha equal to can to 3. Remark. هنا I've studied the case with beta equal to 9. صح؟ طيب لو beta doesn't equal to 9, لو alpha equal to 3, that means this row is 0. بس beta doesn't equal to 9. يعني معناه this number is not equal to 0. هنا هيبقى الرانك بتاع ال A doesn't equal to الرانك بتاع ال A and B. مش بتساوي الرانك بتاع augmented matrix. In this case, I will have inconsistent system or inconsistent solution. Inconsistent system, which means no solution. يبقى هنا ماشي على الكلاسيفيكيشن بتاع الفا ومين وبيتا. طبعا المسألة دي it's really very important problem. It shows us how you are or how you understood this part. You already understand, you have a very good understanding about the ranks. You have the general cases when the system is going to be consistent or inconsistent. So it's a classical problem. Testing your information about the cases of alpha and beta or about the various cases on the classification of a system of equations. You have plenty of problems solved this year about alpha and beta or K and H or variables different than the main unknowns. On them, your solution will depend if it is consistent, inconsistent, if it is consistent with infinite number of solutions, or if it is consistent with a unique solution, and so on. This problem is major. You will have to solve those problems which already existed in the previous 2 exams, and also about this problem. It's very, very simple. I want you also to review the properties of determinants, which is a little bit different than the properties of matrices. What's the main row operation of matrices? Switching rows. Am I right? Multiplying a row by a number. Multiplying a row by a number and adding it on another row. These 3 operations in specific in determinants have various effects. If you change rows in a determinant, the sign or the value of the determinant will change its sign. So if I have a determinant with its value 10 and you switch it 2 rows, okay, the value is going to be negative 10. If you multiply a complete row by a number, let's say multiplying for a determinant 3 by 3. If you multiply the second row by 2, the final result that this determinant, new determinant, will equal to the older one but times 2. But if you multiply a row by a number and add it on another row, surprisingly, you will have the same value of your determinant. There will be no change. These three properties are really very important. Also, there is another difference. If you multiply a number in a determinant, it will be multiplied in one row or in one column. But if you multiply a number in a matrix, it will be multiplied in each row. So look to this problem, one of the also classical problems that usually haunt this part. It's about determinants and the probabilities of determinants. You are given matrix A, which is simply 2, 4, and 4, 1, 0, and 0, negative 1, 2, and 3, okay? And he wants you to find the determinant of 4 of A minus 1 transpose. Think how to do it. This is actually hunting two main things. First of all, evaluating the value of a determinant. Then you understand completely the difference in multiplying a matrix in a number or a determinant in a number. Then also the proposition of the transposition, the propositions of transpositions, how it's affecting the value of a determinant. This is really a very nice problem. I will start. How to evaluate the value of A? Of course, if you closed your mind, you have the longest way. The longest way is to bring the inverse of this matrix first, multiplying the result by 4, getting its transpose, and evaluating the determinant. Am I right? But I have a simpler way. I can get the value of this determinant. Can you evaluate the value of this determinant quickly? What's the most efficient method to evaluate? Sarah's rule looks tempting, but there is a simpler even than Sarah's rule in this case. Look to the row or the column with a huge number of zeros. I think the second column looks really very tempting. If I used the Laplace method to evaluate the value of the determinant, it's going to be like that. I'm going to use the plus method. The determinant of A is equal to, I will use this column. I will use the second column. Remember the sign rule. The sign rule states positive, negative, then positive, then negative. So the value of this algebraic complement or of this number is negative. So I will use negative 1. Then I will eliminate the row and the column. I will have a smaller element, which is 4, 4, 2, and 3. The result directly, just let me check here. It's a 2, 4, I'm sorry. This number is 2. So I will erase these two columns. I will have this guy. Start evaluating. 4 times 3 is gonna be 12. Minus 4, so it's gonna be negative 1 over 12 minus 4, so it's gonna come up to negative over 8. Am I right? تمام؟ طبعا of course I can use Sarah's rule. Okay, if you like to use Sarah's, we can get the value of a determinant by a row or a column, by cofactor method. So I can use, for example, the first row. Taking 2, eliminating row and column, I will have this determinant, which is going to be 0 because it contains one row or one column equal to 0. Then I will go negative 1, eliminating row and column. I will have 4 times 3 minus 2 times 2. Then I will go for the last one, which is positive 1, eliminating row and column. It's going to be 4 times 0 and 0 times 2, and I will have the value. I can do it also using the second column directly. And this is the method that I will use, recommended to be used, with determinants greater than 3 by 3. Okay? This is gonna be easy for this one, especially because it has a column which has 2 zeros and just only one element. I can of course use Sarah's rule if you remember. Sarah's rule states you can multiply 2 times 0 times 3, which is 0. Then 0 times 4 times -1, which is also 0. Then plus 2 times 1 times 2, which is 4. Then minus. This guy is gonna be 0, multiplying the elements of secondary diagonal. Then 2 times 0 times 2 also is gonna be 0. Then 1 times 4 times 3. 1 times 4 times 3 is gonna be
12.
minus 12. 12. So the result will be also negative. In anyhow, I have the value of this determinant. But I have the value of which determinant? A determinant. But I don't need the A determinant. I need the determinant of the inverse of this matrix. I know from the properties of matrices that the determinant of A minus 1 is equal to 1 of the determinant of A. This is one of the properties. Also, I know the determinant of an inverse matrix, it's equal to 1 over the determinant of A. So simply, for A minus 1, it's gonna be 1 over -8. This is the value, okay? But I've also multiplied in 4. Multiplying a matrix in 4, it means every row will be multiplied in 4. Yes, ما هو في الماتريسيز بيبقى في الماتريسيز it will be multiplied in all elements. But in determinants, once you multiply by a number, it will be multiplied by one row. But انت مش ضاربه في الديترمنت، ضاربه في مين اصلا؟ في الماتريكس. سواء اذا كانت الاي ماينس 1 او كذا. يبقى اذا النمبر اللي انت بتضربي فيه ده هيبقى 4 to the power of كام؟ of 3. ماشي انا معاكي. ما هو الاي ماينس 1 دلوقتي انا عارف الفاليو بتاعته اللي هو كام؟ صح؟ تايمز ال4 دي الافكت بتاعها على الماتريكس بتاعت الاي هي عباره عن 4 to the power of number of rows. تمام؟ طيب كل دول انا جايب لهم مين فوق؟ ترانسبوز ما بيأثرش على الفاليو اوف الديترمنت. يعني لا الفاليو بتاعت الديترمنت it's equal to the value of the matrix if it is transposed. Both of them equal to each other. الانفرجن بيساوي 1 على. فخلي بالك بص خلي بالك الحته دي اختبرت كام حاجه؟ probabilities of determinants, probabilities of inversion and determinant, و probabilities of transposition. So it's very simple. So all I have to do is to get 4 to the power of 3, which is gonna be 16 times 4, I believe it's gonna be 64, times -1 over 8, which is gonna come up to -8, and that's the value of the determinant of 4a minus 1 transpose. That's gonna be the result.
ده اسهل بكتير قوي لما اجيب الانفرس.
طبعا الطريق التاني طويل قوي. بس طبعا خلي بالك انا عملت ده لو انا عارف ايه؟ probabilities بتاعت propositions. Okay. I think by this, as I told you, it's very important to review the addition, the multiplication, as I told you in the previous lecture, going through the propositions of everything, the probabilities of matrices, the inversion, the transposition, and also with the determinants, with the problems of solving a system of equations, with how to evaluate a determinant successfully, with all the long processes that we had. I want you to focus. The exam is going to be simple, inshallah, and best of luck for all of you. Thank you very much. Thank you.